In this video, I'm going to go over a little more on composite functions. The first part of which is telling whether a set of composite functions is commutative. What is the commutative property? It says that it doesn't really matter of the order of operations sometimes, but two expressions can be equal to each other, just like a plus b is equal to b plus a. Now, what does that mean with composite functions? Well, it means that no matter which direction you make the composite function, f of g of x, or g of f of x, both of those would be equal. If those are equal, that means it would be commutative, right? Just like a plus b equals b plus a, or a times b equals b times a. Same thing. Now, to check that is to actually do it. So I'm just going to practice some composite functions now. F of g of x. Okay, well, we start with f, and we replace the x with g of x, which is 3 minus x, right? And then we complete it. So we just took 2x plus 1, and instead of x, we put g of x. Okay. Now, there's parentheses around what we substituted, so we got to distribute, right? 2 times 3 is 6 minus 2x, and then we have that plus 1 hanging out there. All right, combine like terms, right? 6 plus 1 is 7 minus 2x, and that is f of g of x. Okay, let's see if g of f of x gives us the same thing. So 3 minus 2x plus 1. Well, we have a negative 1 there, right? So we still got to distribute. So 3 minus 2x minus 1. 3 minus 1 is 2 minus 2x. And that is g of f of x. The minus 2x is the same, but the 7 and the 2 are different. So these are not commutative. All right. All right, I have another set example I want to do. All right, so f of g of x on this side here is what? X plus 1. Okay. X plus 1, that was easy. What about g of f of x? G, replace that x with an x plus 1, and bam. So they are commutative. That was probably the easiest problem I've ever done here. Basically, f of x could have been anything, and g of x equals x. If g of x is just x, that's going to be commutative. There's an example. All right, on to part 2. This is more of a conceptual question rather than actually doing any math, because we don't have the functions of f of x and g of y that they're giving us. They're just telling us what they are. What are they telling us? They're telling us what the input of those functions are and what the output is. Not the exact numbers, because that could be any numbers. They're variables, right? But they have units of measurement, because this is a word problem. So we need to use the concept of composite functions to figure out this question. Okay, so what is the question? Suppose f of x gives miles that can be driven in x hours, and g of y gives the gallons of gas used in driving y miles. Which expression is meaningful? Meaningful? I mean, there are meaningless expressions. Yes, there are meaningless expressions. Okay, so they're asking if f of g of y is meaningful or g of f of x is meaningful. One of them is not, I guess. Okay, well, how do we figure that out? Well, let's write down what we know. What is f of x? Okay, f of x gives miles that can be driven in x hours. Okay, think about that sentence for a minute. F of x gives miles. Okay, if it gives us miles, then the output is miles, right? Okay, we got the output. Gives miles that can be driven in x hours. Well, x is the input. So the input must be hours. That is the important information here, right? Now, what about g of y? What is that doing? Well, g of y gives the gallons. Okay, it's giving us gallons. So its output is gallons of gas used in driving y miles. Y is the input here, right? So the input must be miles. Okay, so they have miles in common. Well, what does that mean? Well, think about it for a minute. F of g of y is miles, right? Okay, so if we put miles in here in the g of y, forget about the f of g of y for a minute, just focus on the g of y part. If we put miles in here, then we're going to get out gallons, right? And once we have those gallons output, then we do f of gallons. Wait a minute. Input is not in gallons, so this doesn't make any sense. You don't input gallons and get miles out, sort of. But that's not what that function's for anyway. Let's try g of f of x. Okay. I have a feeling since we eliminated that one as an answer, then this is going to be our answer, but let's just make sure, shall we? All right. So f of x is the hours, right? So f of hours, do that part first, and then we focus on the g part. So f, put in the hours, and we get out miles, right? The output of the f of x is miles. So now we have g of miles. Input for g of y is miles, so that makes sense. Therefore, g of f of x is meaningful and f of g of y is meaningless. Thank you for watching.